Now, as I referred to many times before, double integrals find volume as long as we have a function other than 1 in our integrand. So if we have some region here on the xy plane, of course, it doesn't actually have to be on the xy plane, it just usually is. And then we want to find the region of some three-dimensional surface that is cut out by that region, right? So that region on the xy plane has a shadow cast up onto the ceiling of the surface. This surface is z equals f of xy. All right, so when we find the double integral, what we're doing is we're taking volume, which is area times height, right? So volume is area times height. But of course, because this is a three-dimensional object and because it's all curved and everything, you can't just use the regular geometry formulas. You have to integrate through calculus over that region of the height function with respect to a. And so the way that works in practice is you're taking the double integral over the region of f of xy dA. And of course, it doesn't have to be x and y. It just usually is the way that we refer to it. But it technically could be y and z. And then you're integrating sideways. That happens too. Okay, so let's look at the volume of the solid bounded by the xy plane and the surfaces such and such and yada yada. Okay, so this is a particularly tricky one to see. So z equals 4 minus y squared. If you remember from our section about three-dimensional objects, this is a cylinder that is parallel to the x-axis. So this is going to be fun to draw. So we got to draw, let's see here, x, y, z. So x is coming out this way. So it's a parabola, right? So we can draw a parabola. We know what parabolas look like. So it's a parabola right here. And then it comes out parallel to the x-axis. Sorry, that wasn't perfect. It didn't join up exactly as I wanted it to. There we go. Okay, so we have this parabola, and it works like that. Now, we're not doing the whole parabola, thankfully, because it keeps going forever, so we can't do that. Right? This is a paraboloid. It's a cylinder, excuse me, it's a cylinder, so it goes forever in the x-axis direction. So that's not going to be any good. But we want to cut it off at x equals 0 and y equals x. Y equals x is a diagonal line. Let's think about that. Y equals x comes out like this, right? That's what y equals x looks like. All right, so that has its compatriot up here. So the zone, the three-dimensional object is right there, and the region of integration is down here. Right? There's the region of integration. So we're actually taking this surface up here, right, that's bounded right there. Here, let me kind of give it some color here. So here's this surface in here, and we're taking the volume of that section of it. All right, let's redraw this region in the xy plane, right? So let's draw that. Y equals x looks like this. And of course, this is the y, so the x piece has no color, so it's going like this. Right? So this is y equals x right here. And then what is this zone? Well, we've got to figure it out, right? We have to figure out where this is touching and where it's touching here, right? So we need to know these values. Now, to figure out that value, it's this same value right here, right? So remember that this surface is z equals 4 minus y squared. So 4 minus y squared would hit the y-axis, right? Z equals 0. So if I say, hey, 4 minus y squared equals 0, that would mean y squared equals 4. That means y equals plus or minus 2, which is, this means it's hitting at 2 here and at negative 2 over here. Not that I care because the other side I'm not using. So 2. So this is y equals 2 right there. And since y is equal to x, that means that x is also 2. Nice. All right. Now we have to choose which direction we're going to go for our integration. And to be honest, it doesn't really matter that much in this case because the integrand is easy. So we have a double integral. To find the volume, we would integrate the height. So we need our height function here, the height of the surface. And the height of the surface is 4 minus y squared, right? That's our f of xy. That is equally easy to integrate with respect to x or with respect to y, so I'll do dx dy just because I feel like that is one we always need more practice with. Now dx dy is horizontal, so if we go this way, that's dx dy. Okay, so y is going from 0 to 2. We just figured that out, right? And then x is not numbers, right? It's not numbers because a lot of students want to say, oh, it's 0, 2 also. No, it isn't, because this isn't a rectangle, right? This is a triangle. So we start at x equals 0 over here on the left, right? So on the left, we have x equals 0. I agree, because that's a straight line. Over here, this is a diagonal line, so it's going to vary. So the right side is x equals y. So we're going to use that. So we're going to go from 0 to y, right? X equals y. All right, so now let's integrate it. So we have the integral from 0 to 2 of, I'm integrating with respect to x first, so 4x minus y squared x from x equals 0 to x equals y, right? And again, if it makes it easier for you, you can put the x equals in to remind yourself of which way you're going first. And then dy, because we haven't integrated with respect to y. So then we plug in y, and we plug in 0. 0 is not going to do anything because this is a polynomial. So y goes in, it becomes 4y minus y cubed, because y squared times y would be y cubed. And then putting in 0 makes 0, so we can just ignore that, dy. And then I'm going to integrate that, so that would be 2y squared minus 1/3 y cubed from 0 to 2. I didn't bother doing it in Maple because it's so simple. So this is 8, take away 8/3. Whoops, I don't know what I was thinking. That's a 1/4 y to the 4th. I didn't add 1 to the power. I'm just losing my brain. All right, so this is 1/4 y to the 4th, which would be, I just said it was so easy, but then, you know, that is 16 over 4, which is 4. So that's 8, take away 4, which is 4. There we go. Now, if it was given to us in inches, just pretend. So if it says x, y are in inches, then this would be inches cubed here. And actually, I should have mentioned on the previous example, if this one was inches, it'd be inches squared, right? If x, y are in inches. Because this one was an area for the previous example, and this one is volume, right? Volume is inches cubed, area is inches squared. Sorry, I should have mentioned that. All right, let's go check it in Maple. This is how I knew I'd done it wrong, so I just wasn't thinking. All right, so integrate 4y minus y cubed from 0 to 2, and sure enough, we get 4. And there we have it. And this is the surface, by the way. It's a little hard to see, so I graphed it in implicit plot at first. So you can see it's just this wedge kind of shape in the back. So then I used plot 3D to graph just that wedge piece of it, right, and nothing else. Right, by graphing 4 minus y squared and 0, and then I kind of looked at it. And I could see it was just that triangular wedge piece in the back.